Hi, I'm Tom Cantor, a Microsoft PSP and Integration MVP. And today we're going to talk about using Azure with facade layer in front of it for security to meet PCI and HIPAA compliance. Going to talk about the web app layer of the platform services that the Azure provides, web app and service bus and service bus relay, and combination with the on-prem hybrid access with BizTalk server. First off, what we're talking about is providing a security boundary in front of your on-prem service. Needless to say, all of these installations, PCI, HIPAA, and so on and so forth, require some kind of security boundary. And where we put that and how we implement that is important, and we'll be talking about that a little bit. So looking at Azure security boundaries for your enterprise, regulatory compliance are often encountered, and these requirements of specific implementations, feature sets the vendors over the years have slowly built, and they can be a little difficult to meet. Sometimes they don't meet out-of-the-box functionality that you may see with the Azure capabilities. And so we're trying to add that PCI security layer on top of that so we can easily connect out-of-the-box services into your hybrid connectivity. Starting with a cloud approach at the boundary gives you a strong, highly secure boundary to put your information behind. I've heard the comment from various architects over the years about how Azure itself is under constant security attack and is their default behavior. That is how they operate. Putting your security layer behind that gives you a pretty powerful story and makes it easy to hit the mark on these. As far as HIPAA security goes, every component in Azure is HIPAA certified, and they're continually testing to make sure everything in there is done. Now, on the Azure side, of course, they're already dealing with all of the different kinds of attacks, and they have processes and controls in place that they're more willing to discuss over time and beyond the scope of this lecture, but they're very deep. And it seems advisable to me to use that as an edge for your own security to start out with. So we'll talk about how some of those fit in there. So why do we care about security at all? What types of security are we going to be encountering? What methods can we use to have that meet that security layer? Well, we've all seen massive data breaches, unfortunately, over the years. We don't have to enumerate them during this session, but we're all well aware that there have been errors in that area. Regulations like HIPAA and PCI and PHI security all are in place, help guide companies make good security decisions. So one of the things that we run into at the actual types of security that we run into are things like in PCI security, you might be sending a payment processing over to another entity over the internet, and you want to be assured that that hasn't been tampered with. So that there are ways to mark up that message and make sure that it's unmodified and non-repudiatable. So in HIPAA, we're making things like insurance reports. We're telling people about our insurance, what kind of procedures we've had, what our payments are coming from, credit card information, so on and so forth. And then in these external vendors we have to integrate with, they've already created systems that work, meet all of the regulatory compliance. We have to be the ones who conform to their requirements and make sure our systems communicate with them and integrate with them. So part of it is trying to make that work well. What is the goal here? Well, the goal of security in general is to prevent unauthorized access to the information. And also, it's important to make sure that people have authorized access can get to it. Denial of service attacks are a method that they use to prevent you from getting access to information. And mandatory compliance areas like this in finance and healthcare, PCI and HIPAA, mandate that these must be met and that they must fall within this regulatory area. We start out with an approach called TMA, threat model approach, and we look at detailed areas about denial of service, information disclosure, elevation of privilege. These are the areas that we'll categorize when we're looking at this. We're going to be talking about a couple of them here today. The typical thing is that these outside vendors that we work with, there are any payment processors or insurance companies, they're already out there and they've already mitigated all of these issues. And working with them to align with their requirements, we can easily find out how we can make our system compliant and build a system that will mitigate these threats. We're using the facade approach in front of Azure to meet these mitigation approaches because we know already behind us once it's entered into the Azure cloud, we've already met all of the requirements. So types of security that we typically run into. A lot of the security is in-flight encryption. So you'll see the icon on your page. Everybody knows this pretty well. On the browser bar that shows us that we're running over an encrypted safe connection. But once the data arrives in a remote system, we want to talk about making sure that that's secure. It's either encrypted in the secure storage or in a place where people can't get to it. It's behind a secure firewall or a secure data. So we want to make sure that it's stored security, and they talk about bit depth quite a bit. But that's one of the aspects of encryption. How deep, how long would it take a modern computer to break through that security and reverse engineer your password or the encryption data or so on and so forth? And another key thing is you want to protect the secret. The secret is the key that, of course, we use for this encryption layer. All of the standards have some kind of guidelines in this regard. So we're going to talk about one of the three approaches we're going to be using today for the facade layer. And the first one that we're going to talk about is mutual certificate authentication. So this is very simply where both parties have private secure encryption data, and they exchange certificates that say, I am who I am. So very widely used. And for us to achieve that, we do have to provide some custom code in front of Azure. This is the facade layer that we're going to be doing. The key, of course, to this data is that the keys are securely held. They're in secure storage. You're holding them. We're not sharing them with vendors because they just need access. We need to make sure this control is in place and works. Now, these certificates are used, and they do a thing called signature. They sign the outbound connection. So the outbound connection has got a hash, a hexadecimal key associated with it. And if I get that and it arrives on the server, only the sender could make that hash value. And so they build that hash value based on the message. And if the hash that I generate from that message is identical when they sent, I'm certain that it's from the other party. We want to have this because in this scenario, the payment processor or remote system like Salesforce, which is the one we're using in the demo, they will send that certificate. We want to make sure only Salesforce is sending that data to us. Another approach is using hashed values. So we basically take a chunk of the message and they just embed a chunk of that message with the security key in it, and then we rehash it. It's a more manual approach, very similar to the mutual certificate, but it's not. The components need to be a little more custom code and a little more manually processed. It doesn't address encryption. That's usually addressed at a lower level. Finally, one of the methods we're using today is an embedded key approach. So in the embedded key approach, what we're doing is we're putting a unique value inside of the message, and then that unique value is hidden from the users at each end, and it's just transported along. So it provides at least an assurance that the other party, if they're protecting that unique value, is sending you the message. But in all, it doesn't actually do any message validation, but in all these cases, as we're mentioning, all this requires us to put that facade layer in place because we need to provide some kind of code because none of this is going to come out of the box in Azure today. People are buying something. That's the goal here. And in this scenario, we're actually going to be buying health insurance. So this is for a union, and they have an IT division, and the union has brought together 3 different vendors to bring together a solution so that their union members can buy insurance from this. This is a healthcare information exchange system. In the implementation on this hybrid solution, the payment process is a cloud solution. The hosting site, Salesforce, is a cloud solution. And finally, the integration with the on-prem services is Azure Cloud using Service Bus Relay. So over to the drawing. So upstream of us, we've got a payment processor company called Bluefin, and they provide specific services, self-hosting pages. We're going to be pushing that through there. And finally, they're going to be processing the payment and telling us about it. On the lower part, we've got Salesforce. Salesforce has got a capability, community portals that can be highly tuned and can look very specific to your implementation. So it looks, has a look and feel exactly how the customer wants to see it. And they need to reach into the on-premise services because they're not the record container for a lot of what's due, when is it due, how much is due. That business logic resides on existing line of business systems that are at the customer. So we had to bring those 2 systems together and put them into one seamless capability. Azure was a good approach because it gave us that access to the on-prem systems. There wasn't a lot of uplift on the on-prem systems because they didn't have to do things like bring their data through the firewall directly. Azure handled all that for us. Now, once the payment is made, of course, that post back is going to get sent into the payment processing and control system back in the line of business systems. So here we have the PCI security aspect of this. The only components in this are payment data. So we're going to have an insurance, we're going to have a credit card number, dates, CVV2 numbers, their first last name, and this is going to fall within the PCI security aspect. Bluefin uses 2 elements to guarantee this security. First thing is we want a hash, which validates the data, to detect tampering, if there was any tampering with the data in flight. And then at the data layer, we're using SSL connectivity to encrypt the data so that it can't be inspected and reverse engineered from that data. And so by combining that with the Azure Service Bus, it made us have a scalable and secure payment system to get that data in. This is just an example of the method that we use to calculate the hash. So the hash there's a built-in functionality inside of .NET for creating a SHA-256 component, and then we add in all the components together, concatenate them together, and run a hash over them. So what we're going to do here is I'm going to bring that forward, and I'm going to actually make a payment. So I'm going to bring forward the sample code and show you how that works. So I'm switching to duplicate. So in the Bluefin Health Insurance Marketplace, I have a payment form, as we saw. I'm just going to use some auto data to fill that out. And then behind the scenes, of course, we have the Azure App Service. Over here, as you can see in the menu on the left, I'm underneath one of the app services. I'm in a resource group that's been constructed to do this. And I'm going to remotely connect to the debugger. So I want to show this break into the code. And we bring up our default page. And then in the marketplace, I'm going to process that payment. And then this is the call to the service. And in here, this is running in Azure. And then we're going to calculate the hash, basically concatenate those values together and run a 256 SHA over them. And the goal here is, of course, to return that result. And then from that result, we have a calculated hash. And simply I take the value that they gave me in the inbound message and the value I calculate. And if they are not correct, I will return an error. But they are correct. So we're going to post this to the line of business system via the service bus. And this is a typical send data service bus, get data back, and forward that on. So I'm going to come out of there. And one more step. Great. Now in the back-end system, I'm tracking this data. This is the BizTalk application group hub. As you can see, we just sent that data in. The local time there, 18/8/16. And we can see the JSON posting value and the hash that we did see in the original message to validate it, transaction ID, all the technical information, and it was approved, authorization code, so on and so forth, details. So these are then inserted into the tracking system in the line business system at the customer site. Fairly straightforward. The keys to this were in the implementation. We use, of course, the MVC model controller to manage this. And then we take a generic post to receive the data. There were some iterations where sometimes we would receive XML and sometimes we would receive JSON. We got that sorted out, but this approach, as we ended up fairly straightforward. All right, so further on in the PCI security, we're looking at the actual page where we're going to make a payment, that page. And behind this, we're querying to find out what does the customer owe right now. So we're going to make a lookup into their membership due level and what they will be owing for these next couple of quarters, and then they get an opportunity to select that. Now this is a round trip lookup, so I have to. The service bus itself is a one-way direction flow, so we had to use the service bus relay, which allows us to call in. We still needed to put a mutual authentication between the two calls. And this was a new feature, just came out in May, I believe. The key here is to enable mutual authentication. The two components that are communicating, the requester starts the conversation over the SSL connection. But the server, us, needs to tell them, by the way, I'm going to require you to send me your certificate. And this code sample here shows the method that we use in PowerShell to turn that property on. It's currently not accessible via the management portal, and so it requires direct manipulation of the property stack. There's a good article by Nazim Lala that presented this, and I was able to follow the instructions there, and this was how we were able to get Salesforce.com to send us the certificate. It's a feature that they've had for many years, but we needed to have the server side be able to do that. And so now this is available to us. And this simplified the security because once we did that, we could then hash and validate that. In that component, this was the querying on-premise services. And in the controller here, I now have a class that I've created, a generic class that's going to be used many different ways. But it basically allows a post of a JSON object. And then we have various, we're going to be primarily forwarding that in the service bus and then receiving a result. In here, the validation is actually occurring in the initial service bus call. So, or when they call our service, there's an on authorization event that's fired that we implement. And then the on authorization method, we then validate the certificate by consuming the existing certificate. Now in Azure, we're already behind a firewall at this point, and the header information that normally comes through has been already stripped. But what they have done is they have promoted that to a separate header component called XR client cert. This now is the brought forward header component that has the X509 certificate embedded in it. So we pull that out, and if it is available, then we construct the 509 certificate from it. And then once we have that, then we validate the certificate by comparing what we have configured in the configuration of the system, verifying that the date timestamp is correct. And you could do some other validations in here, and those are some of the examples are given. But once we've validated the thumbprint, then we come out and we allow the connection to continue. So this allows us to stop the connection very early in the connection process if it's not valid, and a much lighter weight cost to the system. So this could get dropped very quickly and discarded instead of allowing it to get all the way into the on-prem system and come back out. For HIPAA compliance, HIPAA is primarily concerned with 17 data points in a member's information. Needless to say, most of them are covered in this form that we would be filling out online for a new member to have his newborn join, become covered by insurance policy, and so on and so forth. First name, last name, date of birth, so on and so forth, age, zip code, all that information that we want to have to confirm that they are eligible for the insurance is also under HIPAA mandate and security. So for this, we used a slightly different approach. The two-layer validation is the hidden key approach, and that approach will bring forward a hidden value, that large hexadecimal value that's embedded in the message on top of the SSL encrypted value. And so that then sends the data to the WCF endpoint. So it goes a little further into the system. And then in the WCF endpoint, in the WCF event, we grab the message after it's been received, and then we locate that value in the code, and then validate it against the configured value. So in that, we have a custom WCF behavior that we developed for that. And in here, it mostly registers itself with the system and gives us a class of properties, and then the core element, of course, is the walk of the values. Confirm that the value is as expected, and if it's not, the connection will be rejected, so it will be dropped at that point. What we've seen is how Azure provides this deep and flexible tooling for security on top of, by allowing us to put a web facade in front of the Azure access. Just be aware that security requirements abound. There are many of them that you have to be sure that you comply with. And the ability to block these inbound connections at that outer boundary simplifies your security in the internal enterprise, because by the time the connectivity comes into your enterprise, you know that it's already passed the security checks at your outer boundary. So thanks for joining me in this session and about Azure and PCI and HIPAA security. And this is Tom Kent.